because I don't see it yet.
Yeah, I don't see it yet either. Yeah, now.
Let's check.
Yeah, we are now live on YouTube.
Okay. Because I don't see it yet.
Yeah, I don't see it yet either. Yeah, now.
It's yours, right? It's your YouTube. Okay. So let's start.
We are now live on YouTube.
Okay. Because I don't see it yet.
Yeah, I don't see it yet.
Oops, it was mine laptop. Sorry about that. Okay, hello everyone. Sorry for the interruption. Welcome. It's nice to see all of you here. Today we have a really interesting webinar workshop. Before we start, a couple of simple rules and then a couple of small announcements, and then we move forward with the workshop. So first of all, for those who didn't know, you're joining the PyLadies Amsterdam workshop. We are part of global PyLadies chapter, and what we aim to do, we aim to spread Python as much as possible throughout the world, while making sure that there are some really beautiful engineers and Python developers from different underrepresented groups who have a stage to present here with us. So what we're going to do today, today we're going to talk about what is actually, web app is, and what does it mean to have a web app from the cloud native, built from cloud native components. There is a short disclaimer though, it's not a Django workshop. So what we're gonna talk about today is mostly about the web app per se and the concept, because it's introduction to the, and then you will have some home exercises, and if you're interested, there will be also some guidelines how to proceed further. Regarding asking questions, there are two ways to ask questions. You can ask questions here. We're sending a message here in the chat for those who are with us at Jitsi. For those who are watching this stream at YouTube, you can also ask your questions via YouTube chat. If it's something really, really urgent, we will answer it immediately. If it can wait, we'll move it to the logical part where it's better place to ask this question. So I think without further ado, I give a space to our beautiful speaker. So it's your time now. Don't forget to unmute yourself, and good luck.
Okay, thank you very much for the introduction, and hello everyone. Thanks for PyLadies for giving me this opportunity to present here, and welcome to today's PyLadies Amsterdam workshop. And today I'm going to talk about cloud-native web applications with Python. And well, I'm going to share my screen and stop the camera sharing. Okay, so sharing the screen so I can show you the presentation.
Yeah.
Okay, could anyone see my screen now?
Yes, we see it.
Okay, cool. Thank you so much. And my name is Xiaozhou. I'm a software engineer working at Ultimaker. And Ultimaker is a company which provides solutions on the field of additive manufacturing, and it is usually known as 3D printing. And I will talk a little bit more about 3D printing and how software and how particularly cloud-native web application with Python plays a role later in this presentation. So a little bit about myself. And here on the left, you can see my contact information and something more about me and my photo as well. And I'm a full stack software developer who's mostly focusing on backend and sometimes also on front end as well. And if backend or front end is something that's still not you really familiar with, no worries, because this is what exactly we will talk about in this workshop. And at my spare time, I'm also active in the Django Girls activities in the Netherlands. Oh, by the way, the next one will be in September in Amsterdam. And if you visit Django Girls, you may be able to find that. And don't forget to register if you are interested in the Django Girls activity. And I started living in the Netherlands since 2017. And as a software engineer, I didn't start my career with a computer science background, as you can see here, but I studied chemistry and pharmaceutical sciences. I did a PhD degree in computational pharmaceutical material science. I performed simulations on how atoms and molecules interact with each other, either chemical reactions or predicting some properties based on those physical principles like classical mechanics or quantum mechanics. So that was how I started programming, because you might imagine that during the simulations, there were a lot of data coming out and we need to process them. Okay, so back to the topic. We will talk about cloud native application with Python. So I'd like to ask a question for you. And could you check if the comment function works for you? And by talking about comment functions, I mean that here on the left-hand side, you can see the comment. And yes, I typed something here. So if the comment function works for you, could you tell me what kind of things you use Python the most? Because, well, this event is called PyLadies, so I guess more or less you know something about Python. So could you please let me know, so what do you use Python for the most? Something like data science, data engineering, web scraping, text processing, or something like visualization? Okay, so it's your turn. I will wait a little while.
Yeah.
Okay,
Cool.
I have already seen the answers. Data science, scientific data treatment for spectroscopy. Oh, that's something about spectroscopy. Is it something like physics or chemistry? Interesting. Okay, pharma company. Oh, cool. Yes, yes. That's why I'm here. Oh, cool. So nice to see many variations and the differences about different types of activities you use Python to do. Okay, more answers coming up. Data engineering, machine learning, and okay, something about me and hobbies and machine learning and health. Oh, so cool. Okay. Okay. Thank you so much for your answers. So let's go back to the presentation, because today we will talk more about the web application, and hopefully this will provide you some more insights or some more aspects that Python is able to do, because it is a really versatile language, not only used in machine learning, as you see a lot in the chats, but also like data science and processing scientific data. So it's really diverse. Okay, here's the agenda for today. So we will start introducing the team I'm working at, which hopefully will help you to understand how web applications can be used in combination with 3D printing applications. And we will talk about cloud, web applications, and cloud platform services. And finally, we will combine them together and see how they work together. So the company I'm working for is called Ultimaker, as I said in the beginning. We deliver 3D printing ecosystem to our customers. That includes not only the printers, as you see obviously on the screen, but also software, including Cura. I think this is the most famous software in our company, which is an open sourced slicer. And for someone who may not be familiar with the term slice or slicer, I will talk about it in a very little, in a short while. And then we have the web application digital factory as well. Apart from that, we also have materials. So there's materials booths for 3D printing. And we have applications like product development, manufacturing, and also for the education as well. The basic technology we are using is called FDM, which stands for Fused Deposition Modeling. And what is that? And well, this is a bit off topic, of course, but just a very, very short introduction to catch up those concepts. Basically, with the help of this FDM technology, this extruder, so from the printhead itself, it goes to different X, Y, Z coordinates. Then the materials are added layer by layer, so the model and the 3D print job can be produced. Sorry, just to drink some water. And when we mention the term slice, it means that we turn the 3D printing model here on the left-hand side. You see a little robot here. So we turn this 3D model into a plain text file, which is called G-code file. And this G-code file actually describes each step that the extruder should go to the coordinate X, Y, Z to deposit the material, just like this. This is a very, very fast printing preview, as you can see here. So it actually takes about 20 minutes to finish printing this tiny robot. Okay, then after this introduction of 3D printing, we finally can go back to the web applications. Our team is called Stardust, and we are responsible for cloud-native web applications. And as mentioned earlier, this is the web application to help the 3D printing ecosystem to work nicely. A user can register their account using the account service and then use the Digital Factory application, which is our platform that you can manage your printers and print jobs. And we also have marketplaces where our partners develop their plugins in the slicer, so something can be sliced nicely. And also we have material profiles. So we are not only developing our materials, but also we have third-party materials like from BASF in Germany and also some other material partners. In order to cooperate with them, we have to make sure those profile data are in our ecosystem so their print materials can work nicely with our printers. So finally, cloud computing. And maybe that's too much for you to read out this definition, but in general, that's cloud computing, or well, we just call it cloud. Well, by the definition of Microsoft Azure, which is one of the largest cloud computing provider in the world, is the delivery of computing service, something like server, storage, database, networking, software, analytics, and intelligence over the internet, the so-called cloud, to offer faster innovation, flexible resources, and economies of scale. So you typically pay only for cloud services you use, helping you lower your operating cost, running your infrastructure more efficiently, and scale as your business needs change. Okay, too many things, right? This still sounds vague, but well, hopefully that after this presentation, and you may get a better understanding of what the cloud computing is. But yeah, I can understand this definition is too long, very vague. But in order to help you to get a better understanding, I think it would be nice to look at the history before the cloud computing actually comes. So we are going to introduce a bit about the history of building a website 20 years ago in the year of 2000. Imagine building a website in 2000. In the beginning of the 21st century, your boss wants you to build a very, very fancy software. So as a development team, we need to make a plan, right? And this plan can help you to deliver the products in a better and clear way, so you know what exactly needs to be built. And the team needs to think about, including but not limited to, for example, what do we want to build? And a web application which helps the user to managing their print files, for example. And this is the example that we are going to use today to show you about a web application. And milestones for each phase, like for the first phase, we need to build this, and for the second phase, we need to achieve that goal, and we have to make milestones to keep us on track. And who are the targeted users? It's very unlikely that someone who doesn't have a computer in 2000, which was still very common, someone who doesn't have a 3D printer will use our platform. So identifying the customers is very important to help you to understand how and why the application needs to be built. And last but not least, how many users do we expect? This is very important in 2000. We will see it in a little while. Okay, then the very next important thing, the money. You need to tell your boss how much money you need in 2000. And maybe as a startup company, your boss may have very little budget. So what do you need in order to operate such a web application? So the technical team needs to think about servers, operation staff, maintenance cost, renting or buying a on-premises data center. That's a data center that's managed by your development team. And also, to think about the peak seasons before Christmas or in the summer holidays or before the summer holidays, when everyone wants to finish their work before going to the holiday, we may need some extra computing resources. Otherwise, our website will go down. So this is exactly not what we want. So do we buy those infrastructures, those servers and some other things at once, or do we rent them from somewhere? So yes, you need to think about a lot before building a website in 2000. So unfortunately, this is the very beginning of the story for building a website in 2000. Then the team needs to carry out the implementation and operation and maintenance of the application and think about a lot of what-if questions. So one of the very annoying questions at that time is that how many customers do the application expect at a certain time? How could you predict what is the peak season? So when is the peak hour? It's not difficult to imagine that, during the Christmas, fewer users will use the application, but all in a sudden, something like a famous people mentioned our application, it's all in a sudden become really popular that everyone goes to the application and the application simply goes down because you don't have enough servers to handle that. Okay, thinking about that is already tedious, I can imagine. So on the other hand, if you bring up a lot of servers while the users are much, much fewer than you expected, then to some degree, you are actually burning money. And I don't think this is something your boss would like to see. And furthermore, the last thing is that when the product finally goes up and running on production, is the product still something that the customer really wants? Because, 1 year later, things can change to a very different situation. So there are lots of things to worry and think about before the website is actually up and running in 2000. So in general, I guess you may have a very general overview about how building a website in 2000 works. In general, that's overheads. And there is totally nothing to do with customers or deliver the actual products. You invest a lot and you cannot get that money immediately back from the customer. So a lot of headache issue. Fortunately, we are living in 2022, and do we have a low budget, easy to start option at this moment? Yes, the answer is showing here, the cloud computing technology. And at the beginning of the presentation, we mentioned Digital Factory, and Digital Factory is the product which we will show as a demo today to help you understand cloud-native web applications. So which kind of web applications can be considered as cloud-native? So cloud-native application utilize the cloud computing technology to build and run scalable applications in modern and dynamic environments. A big difference from building a website in 2000 story is that with the cloud-native technology, we rent the services from the cloud providers instead of purchasing all those overheads and maintaining them. So nowadays, major cloud providers they have many customizable services, from infrastructure as a service, platform as a service, to software as a service. Usually, they use the pay-as-you-go model, so you pay only for what you have actually used. So, for example, how many seconds you have used a virtual machine. And more importantly, remember we talked about the prediction for the peak hours and burning money if you don't have enough users. Fortunately, we have auto scale for many cloud providers. This means that, depending on the number of users, the cloud service automatically scale up or scale down to make a component faster or slower, or to scale out. This means to add more discrete units of a system, like more CPUs or more memories. Okay, so depending on the number of users calling your service, it can be automatically scaled. So you don't have to worry about those, renting machines, buying machines, and predictions anymore. This is no longer a headache, fortunately. A little bit about those something as a service in the previous slide. So here is a chart about what are on your hand to manage and what are managed by the service providers. So if everything's on site, the leftmost column, you can imagine that you have to use very intense effort to manage everything. Different columns in this chart represents different level of services. And the greener a column is, the more manual work that you have to do. So like software as a service, you simply do not have to manage all this, from the networking to the applications by yourself. They are just running by the cloud providers. So far, we have talked about the cloud computing. After everything has been built as code in our local environment, how do we deploy and ship them to the cloud? And our digital factory is running on Google Cloud Platform, so one of the 3 biggest cloud providers. And to be precise, we use this service, which is called Cloud Run, and this is a managed cloud platform that lets you run containers directly. And containers, we will talk about it in a very short, and on top of Google's infrastructure. So as you see in this slide, containers. So are lightweight packages of your application code together with the dependencies such as specific versions of programming language, runtime, and libraries required to run your software services. So basically, we pack our code together with their dependencies to a container with the help of a platform which is called Docker, and to build a container image. And finally, we deploy this image to the cloud service, which is called Cloud Run, and we will show it in the final part of our presentation to deploy something to Cloud Run. But due to the limitation of the time today, we're not going to dive really deep into Docker and the technology of containerization. So if needed, you may refer to this link for more information. Okay, after the successful deployment of our code and dependencies to the cloud, it's up and running. And we were very excited to show you this application now. Let's go and have a look. So this is the digital library. I have already logged in. And as you can see here, I can, see some projects that my colleagues share with me. We will go back to this application, in a really short while. But now let's do a summary for cloud computing. So in a very, very short description, cloud computing is the on-demand availability of computer system resources without direct active management by the user. So you can just run things or with some mouse clicks on the cloud platform, and it is ready for you to use. At this moment, there are 3 major cloud providers. I think the biggest one is Amazon Web Services, and AWS is its acronym, and Microsoft Azure and Google Cloud Platform GCP are pretty big as well. And our digital factory is hosted on Google Cloud Platform. I believe at this moment you already have a lot of questions. Yes, of course. And one of the questions might be that, so you might wonder, all we have done was delivering a Docker image to the cloud platform, and that was basically it. And the answer is already showing here. No, that's not the case, of course. And what else? So I have already listed something here, but this is only a tip of the iceberg. There were so many things to consider, including but not limited to databases, message queues, logging, alerting, load balancing, and code repositories, CI/CD pipeline, and many more. Okay, indeed, there are many things. But no worries. Let's figure out the direction now. Okay. And we just finished the first part, which is what is cloud computing? And in the next session, we will focusing on 2 things. So the third thing is about what is a web application? And I have a snake here, which hopefully represents Python. And yes, and I will tell you more about how Python plays a role there in a web application. And then we will talk about combining the cloud computing technology with a web application. Let's get started with the very boring definition. Okay, what is a web application? A web application, or in short, web app, is an application software that's stored on remote server and delivered over the internet through a web interface, usually a web browser. Okay, not everyone likes definition, especially long definitions. They're abstract and, they're difficult to grasp. So we just seen the application digital library. We will show you as an example here to help you understand more about it. But before we going into the anatomy class of digital library, you may wonder and think about the terms or jargons regarding web applications. Yes, I believe that you have seen a lot of terms that are relevant to web applications, from programming languages like Java, Python, and JavaScript, Go, and to web frameworks that help you to build the user interface like React, Angular, and Vue. And you may also heard about something like front-end and back-end, but something might not be very familiar with, like DOM, events, requests, response, and API. Okay, I can understand that some people might wonder what is what, and are those jargons really necessary to understand during the learning procedure of web applications? Well, people like my parents may have totally no idea about those jargons at all. So, well, just as the second question to you, I would like to learn from you that about the web applications, so the terms about web applications, and just in the chat, you can list some terms that you have heard about web applications. Like I can list some examples on DOM is, well, like the browser, well, not the browser, but well, the document structure of the website. And there are also something else. So just start listing something that you heard about regarding web applications. Server client model, yes. Okay. Logic, nice. Oh, the MVC structure. Oh, nice. Well, the model will control it. The design pattern. Nice, really nice. CSS. Oh, cascading style sheet. HTML, nice. So, well, to give you some hint, think about some web apps you may have already used, like the online shopping or takeaway order system, or well, the system that you use for making an appointment with the doctor or to the corona test or vaccination, whatever. Authentication, okay, that's really nice. Authorization, oh, that's already that's a good one. All right, I think we can go back to our presentation because, well, we have limited time, unfortunately. So here we will use digital library as an example. And first, thank you very much for the contribution, for the things you know about web applications. And sorry, I can tell you that some of the terms that you listed in the chat, we will going to cover them in our presentation. So let's go back to the digital library, which is visited here. And digital library is actually one part of the product which called Digital Factory, and it's used for managing your print jobs and files. So here is the thing. I visit digital library, and then it gives me a list of projects that I have access to. So you might wonder, where are the projects coming from? So that must be created and stored somewhere, right? I guess someone may have already guessed it in the, well, chat. That's the database, but we will talk about it in a short while. And now I'm going to show you something else. We are going to create a new project. Okay, so let's give it some funny emoji, a robot, because we are going to create a new project, which is called Autobot. By the way, Autobot is the mascot for our company, Ultimaker. This is a demo project. Okay, so next, I would just go directly into this project. So there's basically nothing here. We haven't updated anything or uploaded any file. And this this is the description I just entered into the form that you see just now. And here it says, drag and drop your file here to upload. Okay, I will upload something. I have something here, so that's my Ultibot file. I can drag and drop, yes, drop files to upload. So it started uploading, the uploading is successful and not available data yet, but yes, something comes up. Okay, so after a few seconds, what did you see from, well, no available data yet to a thumbnail image of this little cute robot to the information like, well, how long does it take to finish the print and what are the print calls, which kind of material is going to use. Yes, it was uploaded less than a minute ago, I know, yeah. So it will take 22 minutes to, well, print this, to finish the print. Okay, so, well, how does it work under the hood? And this is what exactly we are going to uncover in the presentation. We go back to our presentation, yes. So you often hear about the word front end in the context of web development. So basically, front end usually refers to an interface, a graphical one that users directly interact with. So in our case, this is the, well, graphical interface we interact with to upload our file, create our project. And for web applications, this front end usually runs in a browser like Chrome, Microsoft Edge, Safari, or Firefox. And what are the programming languages that a browser can understand? And there are basically 3 of them. HTML, which basically, well, is responsible for the contents, like the text displaying here, including this emoji. And we have CSS, I saw that in the chat, which is responsible for styling and to make the page looks beautiful, like all the things, the gray background and the bottoms, well, the blue background of this bottom when, well, when who is on this are all controlled by the CSS. And also JavaScript as well for the effects, like the drag and drop that you just seen, and also many of the effects. And if I click this upload file, it will pop up a, well, file uploading window. So these are all controlled by JavaScript. So that's basically, well, when we talk about front end, what does it mean? Okay, we have covered the part of the front end, the graphical user interface that you can interact with. Then after you click one link or button, what will happen? Where does the application fetch the information from? So as seen here on the screen, it is still a black box. But you may say, okay, we get everything from the backend. Now it's something like a black box, does some magic, and then gives some information back to you. So we are going to uncover this black box very soon. This is an exciting part, and we will see how Python plays a role here. So these days, different applications have many things in common, like user registration, authorization, authentication, and routing the different paths to get different types of information. This means if I, well, call this project endpoint, I get projects. But if I call the printers endpoint, I may get a list of printers I have access to. And in most of the cases, we don't really combine them together because, well, we want to split different kinds of information and messing them up just increase the complexity. And we will talk about it in a short while. And well, and also password validation and encryption is a very important part for, well, common used web applications. And this is only a very small part of all the things in common if you want to build a web application. So we have built up, well, the category, a big category of the things you have considered about in, well, building a web application. And if we start everything from scratch, there will be a lot of work, right? And are we really going to reinvent those wheels? So the answer is, of course, not. There's one very important principle in software engineering field, the DRY principle, don't repeat yourself. It aims at reducing repetition of software patterns and replacing it with abstractions or use data normalization to avoid the redundancy. So now you may ask, is there anyone who has already done something repetitive to build something like a web application template or boilerplate for me? And the answer is, fortunately, yes, and a lot of people are doing that. So the solution is web framework. So in general, a web framework is a software framework designed for developing web application, including but not really limited to web services, web resources, and web APIs. They have already implemented classes, objects, and methods that handles the things we discussed in the previous slide, like user registration, password validation, HTTP requests, and traffic routing, so on, so forth. And there are multiple web frameworks available in the software community. And in general, that can be categorized in, well, two fields. And the first field is the server side, which means that they are running on the server that are managed by the web application owners. So you may consider this server side something running on the back end. Those frameworks can be written in different programming languages. So which language to choose depending on the requirement of your software and the availability of the team and many other factors as well. But once you select a development language, then there are some frameworks ready for you to use. And in the case of Python, there are a few web frameworks like Django. Yes, that has been mentioned a lot in our presentation. And apart from that, we also have other frameworks like Flask. This is a pretty old one. And Tornado, which is the one we are using for Digital Factory. And we also have a really popular one at this moment, which is called Fast API. And PyLadies had a presentation about Fast API previously. If you're interested, you can check it out. And there are also client-side web frameworks, which are used for the front end to build up the user interface. And they are actually running on the browser. So that's the difference between server side, the program running on the server, hosted in the cloud, and client side, it is fetched from somewhere like the internet, the cloud, and then running on the browser itself. So some big frameworks that you may be familiar with are like React, Vue.js, or Angular. Okay, after the user requests, like me request, show me a list of projects I want. The Digital Factory UI will make a request to the REST API endpoint with the path projects. And in this handler, there is a method which handles this request. And it takes your request then and pass it to this service, which is responsible for handling the digital library project. And this service, we usually call it a controller. And I have seen someone mention the model view controller model in the chat. So, many of these web frameworks, like backend web frameworks, they use this model view controller model. One famous example is Django. And so this controller contains some code logic to help you, fetch some projects from the database. Give me a list of projects that the user has access to. And also we have thumbnail images. like this little robot image. And also, well, when I see the projects from, well, my colleagues, there are some project thumbnail images, so I can see some very nice pictures over there. And we have thumbnail images, and they're not stored in the, well, database that we usually mean, because databases are not really good at storing those well, image files, because they are stored in binary code. And where do we store them? And in fact, we store them in, well, cloud object storage, which we will be short in the next discuss it in short in the next slide. And based on, so how it works is that so in the database we store the file name and all the information about the file that we just uploaded, and including the well, the name of the thumbnail image. So we only store the file name because that's the plain text. And according to the name, we ask the controller, hey, please find the file with this name in the object storage. Then it will fetch the image from the object storage and give it back to the service, and finally turn it back to the user. Okay, let's look into more details about cloud object storage. So databases are usually used for storing plain text data like project name, description, file names, as we listed here in our example. But in our case, we have something like a binary file, such as this UFP file and our images, or something else like a video, or, well, executable files in binary. You have different ways of storages at your home. Imagine that. You never put your sword directly on your bookshelf without putting them into a glass jar, right? That also works for different types of data. So we usually use cloud object storage for those binary files because, well, as we just discussed, databases are not really good at storing them. So in this type of storage, each object has a unique name, and the object name is stored in the database. Based on a unique object name, we find it in the cloud storage. So that's it. A simple cloud-native web application. Yeah, that's not really difficult to understand, I guess. But you may also ask, what is the endpoint for creating a project, which we have seen before, well, in the demo? We still use the same path, the answer is. But note the difference. The method previously was get to get a list of projects. And now we're using the method post to create a project. There are different HTTP request methods existing. And why, you may ask, we are doing this? And this actually leads to two questions. So first, why are we using the same path called projects, but different methods? And the second thing, what are the possible methods available? Can I just create my own methods, like, well, create something, delete something, update something, and play around with something? Okay, we first answer the question about the same path, different method issue. So we need to define how we present the API endpoint. So the consumers, which is, well, some clients which will read the data and fetch the data from the API. So we need to tell them what exactly is available from this API endpoint, and that's necessary because, well, some third-party applications, not only our digital factory, but also anyone else who might want to develop application based on what can be returned from the API, may need this information. So when they are properly defined, a consumer can understand and interact with the remote service with the minimal amount of implementation logic. Unfortunately, there are standards and architecture patterns we can follow. And in the case of our digital factory, we follow the Open API standards to build our API endpoint, which includes like, well, the naming convention of a path. In this case, we use projects, and notice the plural here. And also which method is used for what kind of purpose, like get is to get a list and post is to create something. And well, we use different methods for different purposes, so to say. Okay, then the question is that we have a standard to build something which we can follow. And what are the possible methods? So here is a list of the possible methods, which is actually defined by HTTP, Hypertext Transfer Protocol. And it defines a set of request methods to indicate the desired actions to be performed for a given resource. So in this case, if you build your API according to the RESTful API the way of implementation, then there are limited methods which you can use. Some of them are for read-only purpose, like get, and this delete is obviously for deleting something, and post and put and patch are often used for updating and creating something. So if you build a web application and follows this standard, other developers in this world will be easier to understand your API structure. Just imagine our natural language. If we written something down in a certain language like Dutch or English, other people will find it easier to understand, right? But if you create your own language, well, I guess that might be very difficult for someone else to understand, and you have to explain a lot. So a good practice in the software development field is to follow the standards if they are available, and also the dry principle, which we mentioned before as well. Okay, the final thing, remember this uploading part, and we upload file, and a few seconds later, the metadata comes up, like, well, the print call and how long does it take to print, and how's that realized? Sorry, water time, and if you want to drink water, please feel free to do it. Sorry about that. Okay. Okay. Now let's. Is that possible if I continue, or you want a very short break before we're diving into the last topic, which is about microservice and event-driven architecture? Just let me know in the chat so I can have a look. Break. Okay. So shall we say we come back at 8 o'clock in the evening? Yes. Break, please. Break, please. Yes. Okay. So we come back at 8 o'clock.
Yeah. So we have like 6 minutes break, right? Yeah. Great.
Yeah.
I will add Amsterdam time.
Yeah.
Okay. Let's take a short break. And for those who doesn't want to have break, you can just think about how the Jitsi that we're using, how the Jitsi web application works in a browser. What could be the components of it, right?
Okay, I'm back.
Great.
Shall we wait for a little while? Like 1 minute after 8. I'm still sharing my screen, so I think that's okay.
Yeah. But I think
Yeah.
I think we could start.
Yep. I think I'm going to start now. Okay, welcome back after the short break. And we started from talking about the final thing about uploading the files. How was that realized from uploading a file to finally the metadata of the print file comes up to our browser? So I will show you how that works. And when talking about this, we have to introduce two very important concepts. The first thing is about the microservices architecture, and the second thing is about the event-driven architecture. In fact,
live streaming is on.
Yeah, and just 1 second, we want to make sure that it's propagated properly on YouTube. So we can
just give me a signal when it is ready.
Yeah.
Yes, we're back online.
Okay, thank you so much. Okay, so there are not always pros on something without cons. So there are also some disadvantages for using cloud-native web applications. Of course, we have seen a lot of advantages, like it's cost efficient, particularly when you want to start it small and you want to start it from scratch. You definitely don't want to invest a lot to purchase those big servers and machines. And the auto-scale functionality is very helpful, and it saves the developer's life to maintaining and think about the predictions about the resources. And automation and flexibility is also very nice to have in cloud native web applications and the cloud computing technology. And it makes it faster to release applications and no overhead burdens, of course. And there are some also disadvantages for that. For example, the management can be complex, particularly if you have a rather large web application. And then you may have many containers, and how to orchestrate them is a big issue. And there are a lot development operation people, we call them DevOps, to manage them, but this is not something that's really easy to do. And also Terraform configuration to configure the cloud platform properly with a rather large application, because you can imagine that many of the mouse clicking jobs are still tedious, particularly when you have a very large application. And one of the disadvantages is of course the cloud provider reliability. So think about this. If you have an application running on a cloud provider, but the cloud provider has some issues with their data center, and the data center experienced some earthquake, then your website is down, because there's no electricity, and some of the servers may be destroyed because of the earthquake. But there are some technologies like disaster recovery and repetitions of different servers. But anyway, that's one risk of using the cloud native technology, that you have to be dependent on the reliability of the cloud provider. So that's the presentation of this workshop. So at the end of this workshop, what I would like to do is, we're going to deploy a Django app to Google Cloud Run, just to reproduce the procedure that we mentioned earlier in this presentation. We write some code, and we use Docker to build up our container image, and we deploy it to Google Cloud Run. So this, I promise, will be a very short demo. Could anyone see my screen now? So this must be Visual Studio Code.
Yeah, we see your Visual Studio Code.
Okay, that's nice, because I'm going to type some commands, and could anyone check if they can see the text clearly?
I think make it a little bit bigger. So if you just increase it, it will be more readable, I would say.
Yeah, is that better?
I think one more.
One more? Okay,
Yeah.
No worries, one more.
Yeah, awesome, great. Now it's great, thanks.
Okay, and so you can find the information for this demo. You can actually follow this demo in the repo for this presentation in workshop and demo commands. So this is a documentation about this demo. And if you want to have more information or dive in depth into the explanation of Dockerfile and what we are actually doing, you can refer to this document. But let's get back to our, Visual Studio Code. So the third thing that we are going to do is that, we download the file from the repo, which includes one Docker file and the requirement file. So for the explanation of them, you can go to the documentation for for the text, basically. And so what we are basically doing is we will use the Docker file and the requirements.txt to build up a Docker image for our Django application and finally deploy it to Google Cloud Run. And we first install Django. So the first thing I have done is already to activate the virtual environment. And if you like to do that, you can refer to the documentation, but you can also install it if you have Django pre-installed in your computer. I just don't want to mess up the dependencies of my local Python and other environments, so I choose to use this virtual environment, but you can get more information in the document. So we first upgrade pip with Python, pip install upgrade pip. This is something I'd like to do before every installation of some new dependencies. And then we install Django. So pip install, we have a requirement file, so -r to indicate there is a requirement file, which is simply Django version 4 here. Okay, so what it is going to do is that it's going to install, the things that are described in this requirement.txt. So Django has already been installed in our environment. So now we are going to create our first Django application, which we will name it just simply app. We do it with Django admin command start project app. And I just want to start here in this directory, Django Cloud Run. So my application has been created. So you see a new folder, which is called app, and a new file called management.py. And in order to make it possible to run on the cloud environment, I have to update some settings in the Django application. Please note that never deploy the plain text of this secret key to any of the version control software like GitHub, because this is super secret, and please keep the secret in the production secret using an environmental variable. So we only list it here for the demo purpose, and we are going to destroy this Django application soon after this demo. So we are not going to store it in any of the Git repository, and that's why you don't see anything about Django in the source code repository of this workshop. So we need to add, the local host and the Cloud Run website's domain name into a lab host to make sure that this application can be run, can go up and running in the application. So the local host is 127.0.0.1, and the Cloud Run has the domain name .run.app. So this is something that we need to set up. It's also written in the documentation. You can take a look. And now what we have to do after updating this setting file is to build the Docker image. So we use the command, make sure your Docker is running here. And there are some prerequisites for doing this exercise. So you may refer to the prerequisite part in the documentation. And I have Django installed. No, I have Django installed. Yes, I have Docker installed. I have a Google Cloud account. Yes, I have installed a Google Cloud command line interface. Yes, I also have Python 3.10, which is good. And just to save some time in this demo, not to install everything here. So what I'm going to do, I'm going to build an image. So this procedure is here to turn my code into a container image. This container image can be then used to, used by Cloud Run to actually, run the code in the cloud environment. So the command to build the Docker image is docker build. We will name it as app, and we will build the application here in this directory. A simple dot just means, in this current directory. And because I'm using the Mac Apple Silicon, this is something very special to this CPU setting, and I have to add this platform Linux AMD 64. But if you are not using Apple Silicon, this is not necessary to add the final part. So I'm going to build this Docker image. Okay, it's not platform, it's platform. Okay, thank you. Okay, now it's successful, doing something, blah, 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 blah. Okay, after a few seconds, this image has been built successfully. And this command names the image as app and select what's in the current directory as the context to build. So the next thing is that we want to push what we have built to Google Container Registry, which is Google's cloud service to store those container images. So what we need to do is to make a tag for this image. And this image, we called it app previously, and we tag it as gcr.io, which is necessary for the Google Container Registries. Those images stored there, and we need the Google project ID, which I can get it here. This is my project ID, and I called it the application app. So I make the tag here, and this is successfully executed as indicated in this blue light. And finally, I'm going to push it as what we have defined. Okay, so this execution actually pushes what we have built as an image to Google Container Registry. So just imagine upload something to the cloud, but not exactly that, but you can, make it as a comparison to start. And now we go to Container Registry in Google Cloud. A good thing about Google Cloud is that you can simply search what you want, like Cloud Run in this command bar. You don't really have to, find it using the eyes and look it really carefully to find something. You can just type here in the search bar. It's very handy. So now I have seen that my app has been uploaded here, and I have a Docker image here, which showing that like a whale with some Docker, with some containers here. Well, that's cute. Okay, So my container image is ready in the container registry. Okay. So the next thing we have to do is we go back to Cloud Run. Over there, we can create a service. So this service will host our container image, which we just uploaded. And I can find it here. I select this image. So to deploy this image to the cloud application, so service name, we just use the default settings and leave everything default. And we have to set this authentication and allow unauthenticated invocations, just like, well, everyone from the internet can visit my application. And everything we have defined as default in the Docker file, and you may find it in your documentation to get more information. And we are simply going to deploy that, and hopefully everything works fine. This might take about 2 or 3 minutes, I guess, but it might be quicker. Let's see. Okay, it finished in a few seconds. That's so fast. Well, much quicker than I expected. So after the successful deployment, it will give you an URL here, which I can copy, and I will give it to you in this link. So you can actually go and visit this application and see what happens. Yoo-hoo, we get a rocket. The install works successfully. Congratulations. Okay, when you are seeing this from Django, it means that the application has been successfully running and working in our cloud environment, which is a good thing. So from now on, you can start doing some more development using Django, and maybe you can build some nice applications if you are familiar with the web development. And that's basically it to deploy an application to Cloud Run. So the final thing I'd like to tell you is to destroy the application. And could anyone, before I destroy this application, could anyone tell me if you can see the rocket as well from your side? And please leave your yes or no in the comments. Okay, good. Yes. Oh, nice. Okay, thank you. Yes, 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 yes. Oh, I'm so happy about that. Okay, cool. So the final thing I would like to let you know is to destroy this application, because it might induce charges if you don't close it, and this is only for the demo purpose. And we just want to make sure that everything has been cleaned up nicely before the end of this presentation. So you simply go back to Cloud Run interface and click delete, delete app, delete. Then after a little short while, it should be cleaned up. Yes, so it has been cleaned up, which is good. And if you like, there's also one more exercise you might want to try here as the final part of the presentation. So we have introduced something like the different components and elements you might use in the cloud services. So this is actually performed in a development team by the software architect to design how the software works. So think about this situation. When the user uploads a file to a project in the digital library, when this has been done, an email will be sent automatically to all users who have access to that project. And for example, a file has been uploaded to the project Python, please check it out. You will receive that kind of email. And the email sending functionality is also used by other microservices. So like if they send email if a print job finishes. So we have different components like Google Cloud Run, Cloud Storage, SQL database, and message queue. And you might think of a way to combine them in combination with code logic and service, as we just demoed in a previous slide. Try to, well, figure out the elements in the back end in order to do this, in order to finish this homework. And I have a hint for you for this homework. Emails can be sent using external third-party services. The developers provide all the information needed in the email and send it to an external service, and then the service will send the email out. And the homework, this black box, is lit for you for some, well, work or trying out, and you can find the homework and the solution as well if you want to compare your answer to the solutions. So the solution is here, and in the workshop you can find the homework. So you have some place to draw something by you. Then after the homework, it's the end of the presentation. And thank you very, very much for coming to today's PyLadies event. And also thank you very much for your attention. And thank you very much for the organizers to host such a nice event.
Thanks a lot. And we have a question. So eventually there's a question from Josea. I think it's really, really nice question. So what you prefer to read it out loud? You prefer to read it on your own? What's your preference?
Yeah, so normally you have to run manage.py, make migrations and manage.py migrate, but better to wait for the official answer. Okay, so the thing is,
if you walk two up, and also you can switch on your camera so we see you.
Yeah, sorry about that. Okay.
That's great. Yeah, just a little bit up.
I hope to see now. Better to turn on the light. I think this may be better.
Light.
Really dark. So it's already 8:30 in the evening, so a bit dark. Okay. And apologize if this sounds like a silly question. No question is silly. If you have databases that you have changed the models, when you push the updated app, does it also update the database tables? Okay, in the case of our application, we actually use non-SQL, so we use MongoDB. And indeed, when we make some new data in the database, we check if we we'll add something new to the model. But for NoSQL database, adding something new is rather simple, but migrating something might be more difficult. These days, web applications and also the MongoDB library has method to do that. So what you need to do if you need to do those complicated updating is just to execute this migration method together with your code and just following the documentation to do what is expected to do, and you're okay with that. And if you're not really if you're not sure about what you're doing, you can also run something like a lab environment to do some experiments around. So that's always possible in the development procedure. And is that helpful?
I think so. I think if the person has a question, she can get back to us, right? Yeah, you got. Thank you for the answer.
Okay, you're welcome. Okay, the next question given by John is, normally you will have to run manage.py, make migrations and manage.py migrate, but better wait for the official answer. So yes, in this case, we just run the application as a demo to tell you, hey, Django can go up and running on the cloud, and that's it. And the commands make migrations and migrate, they are more about some further procedures. You already created some data models, and you have already composed some code for your data to be entered to the database. And in this case, you need to make migrations because, well, there are some changes in your database and in your model, and new columns need to be added, or old columns which are no longer needed need to be deleted, or something needs to be updated. So those migrations, well, in this case, are mostly relevant for if you have something that has been changed in the database. Does that answer your question? Okay, all right, thanks. Okay, you're welcome. And the next thing, and the next question, Bhumika, is there a reason for choosing GCP over other cloud services providers? That's a good question. So at the very beginning, we didn't deploy our application to Cloud Run, but we used Kubernetes, and Kubernetes was developed by Google. And we use that for orchestrating all the Docker images and services and, well, our entire ecosystem together, and to give the best experience about using Kubernetes. So that was the reason why we choose to use Google Cloud platform, because it has the native support with Kubernetes. We used to run our application on Google Kubernetes Engine. This is another cloud service, well, provided by Google, but that requires more manual work. So the DevOps people or the developers has really in-depth knowledge about how Kubernetes works and how to manage those container orchestration altogether. And this is a really tedious work and not really easy task to do. So that was the reason, basically.
Cool, thanks. And I also have a question. So for those, for example, who was with us for the first time or who's never done anything related to web development in Python, so what is your best recommendation to start learning Django framework, for example?
Okay, so there are some recommendations for learning Django, and I think what I would recommend is well, the official Django documentation. So you just in Google.com and search for Django, and I think, well, the top result would be the Django official website. But if you want to try something else and some more practical exercises or tutorials, I would recommend the Django Girls resources, where they go through well, introduction of Django together with, well, the modern developed technologies like Git for the version control, and they also introduce how internet works, all combined together with the development of such a blog together. So there are different styles of tutorials online, and I think there is also one from the NDN. So that's the website we refer to when we have, well, questions about those HTTP standards and things like that. They have a well, demo project for, well, building a library application by Django.
Cool, thanks a lot. And could you once again repeat this event that's going to happen in Amsterdam? So in September, the Django Girls Amsterdam. I'm curious, it will be
yes.
fully offline or it will
So
be
this
hybrid?
might be an advertisement, but if you're interested in that, I'm going to, well, put the link in the chat very soon, that Django Girls will have the next event in Amsterdam in the headquarters of the ING Bank in the, if I remember correctly, 16th of September, but it might be wrong,
17.
so best to check the
17.
event. So in 17th, okay, thank you.
Oh, 16. Sorry, no, I'm making up things. 16.
Yeah, so 16th of September, it's a Friday. And if you're interested in that, you can sign up, and because there are limited seats. So if you want to do it, please do it quick.
Just to clarify, it's fully offline event, correct? So there will be no online.
Yes, it's a fully offline event indeed.
it's full offline event. Okay, great. Thank you so much. Great job, a great presentation. I think you tried your best to explain the pretty hardcore concepts in a really short period of time. So really good job. I see thank you starts popping up in the chat. We're already a little bit 8 minutes ahead of our time. So I think we're gonna stop the stream for now. And you give also some applause. So it's really nice for you. I will ask you to stay for at least 2-3 minutes more if it's possible for you. And for the rest of the person, thanks a lot for joining us. If you're interested in further workshops, just watch out what's next in our, for example, meetup page. And I think, Bhumika, we can stop the stream